This is a question on complex number and loci. So in this question, the point P in an Argand diagram represents the variable complex number Z. So and the point A in the first quadrant, that means the point A lies in the first quadrant, represents the fixed complex number A, where the Argand arc of A is between 0 and pi over 4. If pi over 4, let's indicate pi over 4 by this line. Right, so this is the angle 45 degree, pi over 4. So that means A could be any point in this area, any point in this triangular area that is between 0 and pi over 4. Right, so A could be anywhere here. Okay, so I just, because A, the actual number value of A is not given, so I'll have to just indicate an arbitrary point in this region and note it as A. And for this question, this is sufficient. Right, then we sketch on a single diagram. They ask us to sketch on a single diagram the locus of P in each of the following. So part 1, it gives us in this form. So we have learned 3 types of loci, and here we have 2 of them. Okay, so one of them is this type. For Z minus Z1, Z1 is a fixed point, a fixed complex number. Z is a variable, equals to, no, not a round bracket, but a modulus, equals to a constant number, for example 4, or any other constant number, right, C. Right, this will give us a circle with center at Z1 and radius C. Okay, so in this case, this looks something like is in this form, but we have to change it to this form for us to picture more clearly what is the locus, what is the center of the circle, and things like that. So although this may look like a complex number or a perpendicular bisector, it is not. There's the perpendicular bisector kind of loci where it's written like this. Right, this is the perpendicular bisector because there's 2 variables, Z and Z. The distance from Z1 is equals to the distance from Z2. So the perpendicular bisector is this line, and where this is Z1 and Z2, and the distance between the Z and Z can be any point on this line. If it's any point on this line, the distance between Z1 and Z2 would be the same. Hence, this is the perpendicular bisector for this type of equation. And then we also have the third type, where the arc of Z, the variable, minus Z1, a fixed complex number, equals to an angle, for example pi over 4. This means that, okay, to draw this type of locus, first step is to draw the point Z1, and then after that mark the positive x-axis. This is parallel to the positive x-axis, and then you measure the angle pi over 4. Right, and then Z could be all the points that fall on this line that I'm drawing. Okay, so Z is this half line. Okay, so here the question is about these 2 types of loci, as we will see why that is the case. But we have to change the equation given to us to this form first, so that it's easy to interpret. Okay, so first thing, how do I change it to this form? First, we note that there should be nothing in front of the Z. Right, so I factorize out the I, so that we have Z plus AI, because when AI multiply to I will have AI squared. I squared is just minus 1, so you give me back minus A. Right, this is how to think of it. Okay, you must find something that will give you back your minus A. Right, so then equals to, now we also know that mod A star equals to mod A, because you see mod A star, let's say A equals to A1 plus A2i, then mod A star is just equals to A1 minus A2i. And notice their mod, right? If you mod them, both of them will give you the same A1 square plus A2 square square root. It will give you the same value when you mod them. Of course, A is not equals to A conjugate, but the mod of A is equals to the mod of A conjugate. That's the difference. So then this is equals to this, and this is equals to this. Then also remember that mod AB equals to mod A mod B. This is another property that we learned in this chapter of complex numbers. So then mod I is here, then we have mod Z. Z plus AI is Z minus AI, right? Okay, equals to mod A. So then mod I, we know that mod I equals to 1, right? If I is on the diagram here, I, so the distance from I to 0 is the origin, the I to the origin is just 1. So therefore mod I equals to 1, so I can just ignore it. So there will be 1 here, but it's not, it's just as if it's not there. So then equals to mod A. Okay, so then now we are in this, exactly in this type of form that we want. So we just need to locate, draw in our diagram. We must find what is our minus AI and draw that first, and then make sure that the distance, then draw the circle of radius mod A. Mod A is a constant. A is a complex number, but when you mod a complex number, what you get is a constant number. So it's a constant number mod A. So this distance is actually mod A. Okay, all the mod A will be the radius of this circle, and the center of circle will be my minus AI. Right? How do I get my minus AI? So first thing, if we draw A here, our AI is just A1i minus A2, because I square will give minus 1, so minus A2. So A1i minus A2. Then we draw the corresponding complex number here. So this is my AI. And when I minus AI, I'll get A2 minus A1i, which is this. It will come to here. So yeah, you can also memorize that when you multiply a I to a complex number, it just rotate 90 degrees. And when you multiply a negative 1 to a complex number, it just goes pass through the origin, and in the negative in the diagonally opposite diagonal and diagonal to it. So you just pass through the origin and go to the other side of it. So then yeah, that's another way to think about that. So then we have minus AI. Okay, then if we have the minus AI, and then we what is the distance of minus AI to the origin, and it's just mod A, right? You can tell that it's just mod A, because if I mod of this one, I'll get this, and I'll get A1 square plus A2 square square root, which is just mod A, isn't it? If I mod minus AI, so that means the distance of mod A from the origin, AI from the origin is the distance of minus AI from the origin is just mod A. So this is mod A. Okay. And mod A is the radius of the circle. So the circle will cut the origin, will pass through the origin. Okay. So that's it. We have drawn the circle. We have drawn for part 1. And in part 2, arc A minus Z equals to pi of 4. We don't want the fixed we don't want the fixed complex number to be the positive one, and we don't want the variable, the Z that we want, to be negative. So we factorize out negative 1, and we have Z minus A instead, right? Then we are in this form, Z minus Z1, right? Sorry. And we are in this form, Z minus Z1. So the purpose is to, again, make Z the constant of the coefficient of this Z, right? A positive 1. right? So I've just factorized out the minus 1, and I have z minus a equals to pi over 4. Then recall that if you have arc AB is just equals to arc A plus arc B. We have that. So in this case, arc minus 1 z minus a would be arc minus 1 plus arc z minus a equals to pi over 4. So arc minus 1, okay, minus 1 is this point, it's a complex number, is this point. So arc minus 1 is just pi, measured from the positive x-axis is just pi. So this will become pi, and if I bring pi to the other side, it becomes pi over 4, becomes pi over 4 minus pi, so it becomes minus 3 pi over 4. Therefore, I'm actually drawing, how do I draw this half line? First, I draw the point A, which actually we have drawn it earlier, and then after that, mark the positive x-axis, and then measure minus 3 pi over 4 in this direction, and then we draw the half line. Minus 3 pi over 4 is just minus pi over 2 and minus pi over 4. Okay, this is equals to minus pi over 2 minus pi over 4. So there have to be a 90 degrees. So this part is just, this angle here, right, actually is just minus pi over 4. This part is 90 degrees. Okay, so together is minus 3 pi over 4. So since this is this angle is minus pi over 4, it should be parallel to this line, because this line, the angle is also pi over 4. Okay. And okay, wait, sorry. Okay, then if that's the case, what else? We have drawn this line, and that means we have done for part 2. Okay, now we are asked to shade the region that satisfy the following inequalities. Okay, notice this part, right? We can use the results. We can sort of right, for this part, we can use the results here. Okay, so if just now it was equal, now it's greater or equals to. So imagine if we come back to here, or we change of all this to greater or equals to, greater or equals to, greater or equals to, and greater or equals to. So we want the part where z is further away from ai than the distance a. So the distance of z from this minus ai, the distance of z from minus ai must be greater or equals to mod a. That means it is outside of these circles. If the distance is smaller, between z and minus ai is smaller or equals to a, then it will be within this circle. Think of it as z as a variable, as the location of a thief. It's unknown now. We don't know where the thief is, but there's a clue telling us that the thief's distance from minus ai, this point, is greater or equals to mod a. So the thief must be somewhere outside of this circle. So we can shade everything outside of this circle if it's just considering this clue that we have. Alright, but we don't just have this clue, we have other clue as well. There's another clue pertaining to the location of z, or the location of the thief for analogy. Alright, so let's see. Besides knowing that he's outside this circle, we also know that the angle that it makes with this a is minus 3 pi over 4. So let's say if I mark a, okay, we want it to be greater or equals to pi over 4 and smaller or equals to pi over 2. So if we use the earlier result, arc a minus z smaller or equals to pi over 4, and this would be smaller equals to pi over 4, smaller equals to pi over 4, smaller equals to pi over 4. We didn't multiply a negative number, so it's always smaller equals to pi over 4. So then when pi we bring over to the other side, so pi over 4 minus pi will be minus 3 pi over 4. So arc z minus a is smaller or equals to minus 3 pi over 4. So therefore here arc a minus z greater or equals to pi over 4 is simply the same as saying arc z minus a is greater or equals to minus 3 pi over 4. So where is it? No, because arc z minus a equals to minus 3 pi over 4 is on directly on this line. If it is greater or equals to minus 3 pi over 4, it has to be in this direction, all the way here. So it could be all the way from in this blue circle. Only, yeah, because let's say if, for example, if it's this point, it wouldn't be minus 3 pi over 4, it might be minus pi over 4. Minus pi over 4 is greater than minus 3 pi over 4. Right, 0 is greater than minus 3 pi over 4. Pi over 2 is greater than minus 3 pi over 4. Pi over 2 here is greater than minus 3 pi over 4. And pi is greater than minus 3 pi over 4. So all these values here fulfill this inequality. So that means the teeth could be anywhere in this region according to this clue. Okay? Of course, we already ruled out this area because it's not inside the circle, right? So he could be there. But then we have another clue. Besides this clue, we also have another clue. We have one more clue. Okay, which says that it is greater or equals to pi over 4. No, it's smaller or equals to pi over 2. So with arc a minus z smaller or equals to pi over 2, it means that we just now already showed that arc a minus z is equals to pi plus arc z minus a. So I just need to change this to arc z minus a plus pi. And the pi I bring over to the other side. So pi over 2 minus pi is minus pi over 2. So this is equivalent, this inequality is equivalent to this inequality. So and now z minus a, so we draw a positive x-axis at the minus a, at the a, and then I draw an angle minus pi over 2, right? So the teeth must be smaller or equals to minus pi over 2, means in this direction, right? In this direction, and greater than equals to minus 3 pi over 4. So it's between these two half lines, right? The teeth must be between these two half lines, in this region, between these two half lines. Combined with the earlier information we know about the teeth, that it is outside of this circle. Therefore, the teeth must, or the location of z must be in this area. We narrow it down to this area, the shaded area. So hence I have shaded this blue area is the answer to this question. Shade the region that satisfies the following inequalities. Okay, this question might be a bit difficult to understand even when I do a video. So let's say if you need a home tutor, you can contact me at this number. I'm located in Singapore. This is my number. So if you have any questions, you can contact me at this number on WhatsApp, and I'll try to explain to you over the phone, or if you live in Singapore, I can explain the question to you face to face.